This is proof.
Hello, everyone is able to hear me? So good evening. I know it's a long evening, so try to keep my talk as short as possible. Has anyone heard about Unity? Cool. I have a lot of hands. So you basically know what Unity is and what Unity does. Do you know what is the new feature that Unity is coming up with?
We are.
Okay.
Yeah.
Okay. Cool. So I'll basically skip through what is Unity because most of the people know Unity. If people don't know, it is Unity is a cross-platform game engine which is basically used to develop games. So as people said that it is also used to develop AR games and VR games, and it has a lot of support. And it is also coming up with a new thing which we are going to discuss about in the next few slides. So have you heard about ML, machine learning?
Yes.
Okay. So I see a lot of small number of yes and a lot of no's. So machine learning is basically a concept to make the machine think like a thinking machine does. For example, make a machine to think like how a human thinks and how he decides what action to take and what is based on the environment or based on certain rewards and etc. So initially it was it was based on the concept of Alan Turing in one of his papers. He wrote, "Can machines think?" From that, people were very interested on making a machine or a computer or a simulation engine to think and act like a human interface. So that is where the machine learning mainly is. And machine learning mainly uses a lot of data. It uses the data, it massages, it finds a pattern, and based on the pattern, it constructs a graph kind of structure which decides which action to take based on the previous state it was in. That is like just of very small version of what is machine learning is. So next, the new feature that Unity is coming up is Unity ML agents. So why do a gaming engine or a gaming engine game mostly game based development engine wants to go into ML? Can anyone take a guess?
Yeah, because you have to challenge the player, right?
Okay.
You want to shoot somebody, he's just standing there, it's not challenging. He has to run around and try to shoot you.
Okay. But till now, the person, like in a shooting game, the person is to run around, right? How were they doing it? Why ML specifically? Why do you want ML?
Because you want to learn how the player is actually responding and make your, the non-player characters to behave accordingly.
Okay. So if you have not heard the explanation, I'll probably reiterate it again. If you take a game like a shooting game, let's take a hunter and a rabbit in a normal typical hunting game scenario. The character of the rabbit had to be hard coded, and there was a lot of thousands and thousands of conditions to be handled. For example, if the hunter is coming up with a knife, then the hunter is in like very near to the rabbit, then the rabbit has to run. But if the hunter is far away, even if they be close to knife, it will not go and hit the rabbit. So these kind of different scenarios has to be thought about, and they were all hand coded, and they had to be tested also manually, and it had to be maintained very manually. So it was becoming very tough and tough. But with using ML agent, you can make the rabbit, train it. You can actually simulate the gaming environment, like if the hunter is coming near, what the rabbit should take. If the hunter is coming far away with a rifle, what the rabbit should do. So these kind of different conditions and environments you can simulate in your gaming engine, and you can train the rabbit and use that rabbit data, like whatever train information that it has trained, and you can use it across multiple games also. That is why the ML agents is being created by Unity, and it's purely an experimental feature for now. And it can also be used by a lot of AI enthusiasts for training their machines or robots or something like that. Let's take an artificial engine robot that they are creating. Let's take a nanny robot or a nanny robot which takes care of babies. So you can build an simulation environment where there's a baby, where there's a home, and what the nanny should do. If the baby is crying, nanny should go and feed it. If the baby is like trying to crawl away, it should go and stand before it, something like that. So this all can be done in the safety of the simulation environment. You don't need to try and test it out only in the real environment where there might be disastrous consequences. That is why we are going into Unity and ML. I'll probably jump directly into what are the different components into Unity and ML. So the main components are, as you know, an agent and a brain and an academy. So agent is basically the person who takes the action, and the brain is the person, just like a human brain. The brain decides whether you should take this action in this environment or you should not take this action in this environment. And the brain also decides if the agent takes this action properly, what is the reward it should get. If you take, for example, if the hunter is coming, let's take the hunter and rabbit example itself. The hunter is coming near to the rabbit with a knife, and the rabbit is running away from the hunter, then it gets a positive reward because the rabbit has performed the right action of escaping from the hunter. But if the hunter is coming, like, is standing far away with the knife, but the rabbit is still running, then the rabbit has done a wrong action. It has run away even before the hunter has come. So it is not a real world scenario, right? It is not the right thing for the rabbit to do. So it gets a negative reward. These kind of decisions and these kind of reward functions are being done by the brain. The academy is like the entire controller. It controls like what is the optimal, how complex the scenario should be. Should it be only with a knife training, or should it be having variety of weapons like let's say arrow, let's say gun or something like that. So the complexity of the environment and the speed and the data, initial data of using to train the agent is being managed by the academy. If you see, there is something called an external communicator, which is actually communicating to a Python API. So in Unity ML, you can actually have models trained outside your system, outside the Unity system, and you can use a Python API and also TensorFlow models to communicate your data to the academy. The academy will communicate your information to the brain, and the brain will use that model to decide and give the agent take the appropriate action. Any questions till now? Okay. This is the basic, I mean, very basic look of how a Unity UI will look like. In here, if you see, I have an academy object, and also within the academy, I have a brain object. So this is how it's structured. And for the objective of this game is for the platform. That's the blue colored platform. To not let the ball fall out of it. So the academy is actually using the brain to control the platform and decide if the let's say a ball is rolling to the right, then you tilt the platform to the left. The ball is rolling to the right, left, then you tilt the platform to the right. So these kind of decisions are being propagated from the brain to the platform. Yeah, the academy. So we talk about different learning patterns, right? The agent is learning, the brain is then giving a reward, the brain has to tell it what action to take. But how does the agent continuously learn from it? So there are different types of Unity algorithms that are being used. One is the reinforcement learning, and second is the curriculum learning, and the third is the integration learning. To make it very simpler, I take probably a school example. Let's say we are in a a physical education class or a PT class. If all the students are let in the back and they are asked to run, okay? So some students will run faster, some students will run a little slow. So the person who is running faster will get a reward, but the person who is going slow will not get a reward, or you will get a negative reward. So this is the concept that is being used in reinforcement learning. So reinforcement learning, it is like starts at a random possibilities. So any agent can take any action. Based on the action, he continuously gets either positive reward or a negative reward. He continuously tries to take different actions. He experiments it and uses the trial and error process to learn if this action in this environment will help him to get a positive reward or a negative reward. That is the basis of reinforcement algorithm. And next, talking about curriculum learning, all of us as humans, we would have started with first and preschool, and then would have gone to a secondary school, and then would have gone to a higher secondary school, something like that. So, if you take a maths class, right, first you will start with basic mathematics like addition, subtraction, then you go to algebra, then you go to calculus, then you go to differential equations. So, curriculum learning is also based on the same kind of thing. You start for a very complex scenario, you will start with a very small subset of actions. If you take the rabbit and hunter example itself, first the rabbit is trained with what if the hunter comes with a stick? What if the hunter comes with a knife? What if the hunter comes with a rifle? What if the hunter comes with a bow and arrow? So these kind of situations are very like trained step by step. So it is like a step-by-step learning algorithm. That is what curriculum learning algorithm is. Then the third type of algorithm that Unity ML supports is called imitation learning. So that's a if you take a real world game, if you take a chess game there are two players. One is a computer player, one is a real world player. So the computer player initially doesn't know anything. It actually copies, if the real world player is actually moving one pawn, the computer player also will move a pawn. If it gets defeated, then it counts as a minus reward. If it gets actually a better advantage over the player, then it counts as a positive reward. So this kind of it learns by imitation. It learns to copy each and every action of the player, and it also gets all the information regarding what is the action is giving as response. Is it a positive reward or a negative reward? Based on it, it constructs a graph of network and it constructs a pattern and uses that pattern in future use cases. That is the three algorithms that Unity is using. So I just made a very simple demo to demonstrate this. Okay, I think my screen is like little bit. This is a basic game that I showed you before. You have a platform and you have a ball on top of it. So if I run the game, I have a academy, I have a brain, and in brain in Unity I have different types of brain. So you have a player brain, you have an internal brain, you have an external, and you have a heuristic brain. So the player brain is actually getting all the actions from the player and it uses it to control the game object. So one more point here, every agent, for example, this ball, this platform, everything is called a game object in terms of Unity. So if the player is like that, you control using the player actually. The internal brain actually gets a TensorFlow model from TensorFlow model or TensorFlow policy, and it uses a TensorFlow model which has a graph kind of structure to control how the agent and what action the agent should take. There's the other option called heuristic, wherein you can actually give them the hard-coded logic to the brain. Tell them that if this condition comes, then you take this. Something like an if-else structure or a tree kind of a ladder or something like that. Usually they use a decision tree for implementing this kind of structures. The fourth way is called external. So if you saw an external communicator with a Python API, right? So the Python API, in Python API you can have certain methods. You can use any kind of algorithms like probability, proximal optimization, some kind of algorithms which is used. And that kind of algorithms you can implement your own code and you can use the Python API to communicate to the external communicator which tells the academy and passes the information to the brain to control each and every action of your agent. Initially for this demo, I'm going to use only the player type of brain and an internal brain. So in the player type of brain, I have this platform. I'm trying to control it with the top hierarchy, up hierarchy, and this kind of hierarchy. Player type of brain is mostly used for imitation learning. So by learning that when I'm moving, the ball is moving towards the right side, I'm trying to lift the left side up. So that kind of learning, this player kind of brain accepts. And I have also built something called a TensorFlow model, which is a byte array, byte file. So the data that is being displayed is not the right data. And if I want to run my already trained model, I can change my brain type to internal. If I change my brain type to internal, I have to export a TensorFlow model for this platform. So this is my TensorFlow model. I'm going to put it. I'm going to use my TensorFlow model as a graph model for this platform, and I'm going to run the game. I have already, for training an agent, you will have to run a lot of trials. I've used reinforcement learning algorithm here. So it was a lot of trials and like 50,000 or plus trials for to get an optimal state for the platform. That is, whatever the ball may move, wherever the ball may move, the platform should not let it fall down. And after trying this, and this is the status of my platform. So how much ever the ball might move, it will not fall off the platform. Uh, So so when there's one more concept called a policy. So whenever you train an agent, the agent is known to be in a training phase. So either you can use a curriculum learning or a reinforcement learning or imitation learning. All the data points will be collected. You can collect all the data points in your Unity code. So this is the code I'm using. This is the code that I'm using to control my agent in a player mode. If you see, there's something called an agent action, which gets a list of parameters for vector action space type, and space type is continuous, and checks for the coordinates. If the ball is within the system or it is outside the platform, and based on it, it sets a reward. If the ball is within the platform, then it sets a reward of 0.1. Yeah, it is like any number that you can give. If the ball is outside the platform, then I set a reward of -1. So that is where the negative reward and the positive reward of has come. So I collect all this information and I use this as a preliminary data set for training my agent. Once I have this data set, I can export it as a Python file. At least you can export it as a Python file from Unity. And the Unity will generate multiple random possibilities with this data set. And you can train your agent, and based on it, you can generate an TensorFlow model, which is what I imported in the previous step to to show my platform that it is in an optimal place. And that's it from me. If you guys have any questions, please you can ask.
Yeah. Um, where are you linking the ball and the platform to the activity?
Yeah. So that you're asking me when I'm linking the ball and the platform
So
to the activity.
everything is the ball and the platform are Unity objects.
Yeah.
Academy is Unity object and it has a brain sub object.
Yeah.
So where are you linking the output of the brain to the actual platform and ball? How do you do that? Is it through the tool?
So if you see, I have selected the platform here, and if you can see the inspector screen, there's something called a my ball agent script that I have included.
Okay.
So my ball agent script is basically the C sharp file that I was showing you, and within the C sharp file, I had something called a brain. If you see the C sharp file, I have this agent class which has been extended. So in the agent class, I have something called a brain. So every agent has to be linked to some agent by default. That is what you need to know. So in my Unity inspector file, when I link my ball agent script with a platform, I get something called a brain which is being required. And in this brain, I have this brain object which I have. So I can sorry, it's in the platform. I can literally grab this brain object here and it will be added to this ball script. So my brain will control what is the data. It is a player, is it an internal mode, it is an external mode, or it is a heuristic. All these game kind of details the brain will tell you. So since the game is running, it is not playing this mode. But you can drag and drop here and it will automatically add your brain to it will link your brain to your script.
So suppose you have trained this in Unity. You have trained the platform and the ball in Unity. How can you export the ball somewhere else?
And that is where the TensorFlow comes in. So if you see this TensorFlow, this is a byte file. You can actually export this with whatever name you get, and you can use it accordingly.
So this is something that is created inside Unity. This is the output of.
No, this is outside Unity. So we have something called Jupyter notebooks that you can use. The Jupyter notebooks you can write your algorithm and then you can run it by each and every step. So once you think you try all the trials are run, you can write an export underscore graph kind of structure. You can use a TensorFlow plugin. You can write some code for TensorFlow, export it as TensorFlow algorithm.
So it's mostly neural network based.
Yeah, it's mostly neural networks.
No SVM or anything.
I think I have a
Is
question.
it possible to get some kind of idea to tensor code?
Sorry?
Is it possible to get some idea about the tensor code?
And I don't have the corresponding agents here, but if you use Jupyter notebooks, you can actually look at it.
So also are you dynamically feeding the data or like this is the trained data? Whatever the data.
Sorry, I'll also repeat the question. You are asking, am I dynamically feeding the data or is it pre-generated data? So the first set of data is coming from, at least the preliminary data is coming from the player brain. So when I play, I actually collect certain agent statistics from it. So I tell either if I'm moving it to the right, am I getting a reward or not? That kind of information I get from the player brain. Use that information and then I build upon that information. I kind of generate a random set of data from it and run through all the actions in a trial state for the agent, and then I get a delta pro model. Did I answer your question or any other questions?
Is Unity still using Mono with .NET 2.0 or they upgraded to 4.6?
They're still using Mono and they're using C Sharp. I think they also have support for JavaScript, but I don't think they have support for their native language quality.
Overall, still on .NET 2.0.
Okay, so if you don't have any questions, that's it from me. Thank you so much.